In today's video, we're going to cover the Arithmetic and Algebra 1 review packet. These worksheets were created by an instructor at the school that I work with, who gave them to me to use for tutoring students and whatever else I wanted to do. They're not textbook problems. These are to prepare students for the types of things that they might see in a Calculus 1 class. So this was our old course number for Calculus 1 up here. And we're just going to go through and cover these 51 problems in this video. That sounds like a lot, but most of these are problems that we can do without a calculator. So the first one is going to cover the idea of absolute value and order of operations. So let me get it written down here. So the absolute value bars are a special set of parentheses, so we're going to have to do them first. Now we're going to have to find the absolute value of those numbers. Now we're going to perform our multiplication. Now we are going to do our addition and subtraction. And last, we're going to simplify our fraction. That will be our final answer. Next problem, we have a complex fraction, which means we have a fraction inside of a fraction. So there's my big fraction bar, and then my little fraction down here. I have 2 times -20 over -5 minus 5. Okay, so that's a the subtraction sign, that's a negative sign, that's a negative sign, multiplication dot, negative sign, subtraction sign. We have in our numerator, we're going to do our multiplication first. In our denominator down here, we're going to do our multiplication first here. And in our denominator down here, we don't have anything else to do, so we'll do that first. Now we have -12 minus 28. It's going to give me a -40 over my divide here. I get a +4. 4 goes into -40. -10 times. There's other ways that you could do that correctly, but that works. Now we want to simplify this algebraic expression. It's got lots of fractions in it. You'll see lots of fractions in these packets because that's one of the things that we wanted students to get used to, is doing arithmetic with fractions. So we're going to distribute this 1/2 to make this 1/4 x minus 1/8. We're going to distribute this 1/3 to make this 1/12 x minus 1/9. We're going to get our like terms together. This is going to be 1/4 plus 1/12 for my x's. And we have a negative 1/8 minus 1/9 over here. We need to make a common denominator for our x part. So I'm going to grab a different color here for a second. I'm going to multiply by 3/3. And then on this one, since there's nothing in common between 8 and 9, multiply by 9/9 here and 8/8 here. So that's going to give me 3 plus 1 over 12x plus negative 9 minus 8 over 72. This can give me 4/12 is going to be the same as 1/3, but I'll simplify here. Negative 17 over 72 is 1/3 x minus 17 over 72. And that's our simplified algebraic expression. Now we're on to number 4. Negative, open big parenthesis, 8x squared plus, open small parenthesis, 2x squared plus 3, close small parenthesis, close big parenthesis, plus, open big parenthesis, negative, open small parenthesis, negative 8x squared minus open small parenthesis 10 plus 8x squared, close small parenthesis, close small parenthesis minus 8x squared, close big parenthesis. Okay, so we're going to have lots of parentheses to deal with here, and that's okay. Just going to have to do some scrolling here. We're going to simplify what's inside the parentheses first, if we can. So keep this negative on the outside. These parentheses here are not necessary for the 2x squared plus 3 because I can't add anything. I'm just going to ignore them, drop them off. I'm going to add my like terms on the inside of that. So 8x squared plus 2x squared is 10x squared plus 3. And it's got the negative 1 sitting on the outside of it. I'm going to come back over here now. There's a plus a negative. So I'll just leave that alone for a second. Plus negative. We're going to have a negative 8x squared. And we're going to distribute this negative 1 over these parentheses. That's going to give us a negative 10 minus 8x squared. And then close that because this negative sits outside of all of that. And then there's a minus 8x squared over here on the outside of that. And we're going to close the big parentheses. Starting to get to where we can see everything all on the same line almost. So let's now do some distribution here. Negative 10x squared minus 3 plus, we can get rid of this negative by distributing. Even though we could combine some like terms, let's get rid of this negative sign. 8x squared plus 10 plus 8x squared. And then off to the side over here is a minus 8x squared. So we have this is all addition and subtraction now. So 8x squared minus 8x squared is going to give me 0. Negative 10 plus 8 is going to give me negative 2. Negative 3 plus 10 is going to give me 7. Now we're going to do some rules of exponents. In parentheses, negative 5x raised to the 0 power minus 5, not in parentheses, x raised to the 0 power. Anything raised to the 0 power, it's not 0, is going to be 1. So we're going to assume that they want us to say 1 minus 5 times 1 is going to be 1 minus 5 is going to be negative 4. Our next problem, we have an exponent outside of a fraction. So the numerator is 4x to the negative second, y to the second, over 12x to the negative fourth, y to the negative first. And all that is raised to the third power. Make sure there wasn't a minus sign hiding there. So 4 goes into 12 3 times. Rules of exponents, I'm going to take the more negative number across the fraction bar to the other number that this, I want to make positive exponents. So I'm not going to get a positive exponent by saying negative 4 plus 2. That's going to give me a negative 2 in the denominator. I want to take this across so that this is negative 2 plus 4. And I want 2 plus 1, like this, raised to the third, so that I end up with positive exponents. So that's what my instructions say. X squared y to the third over 3. And all that's going to get raised to the third power. So when I do that, that's going to, when I raise a power to a power, I'm going to multiply the exponents. This had an exponent of 1, so 1 times 3 is going to be 3. And that's going to give me x to the 6th, y to the 9th. 3 to the third is 27. 3 times 3 is 9, times 3 again is 27. One more of those, number 7, says negative 4x to the 7th, y to the negative 6th, over 9z to the 5th, raised to the, and this is a negative, it's a negative 2nd there. So we can't do anything with this numerical part. I'm gonna leave that alone. We can't do anything with the x's. We can't do anything with the y's. We can't do anything with the z's right now. We're just gonna go ahead and we're gonna take care of this negative 2. Well, one of the ways I'm gonna take care of that is that I'm going to let the negative make me take the reciprocal on the inside. The numerator becomes the denominator becomes the numerator. Now I'm ready to square everything on the inside. So 9 squared is 81. Z to the 5th squared can be z to the 5 times 2 is 10. Negative 4 squared is 16. X to the 7 times 2 is going to be 14. Y to the negative 6 times 2 is negative 12. Now I want to write everything with only positive exponents. So I've got to take this y to the other side. It's going to be 81 y to the 12th, z to the 10th. I write my variables in alphabetical order, 16x to the 14th. Now we're going to deal with some negative exponents. 8 to the negative first plus 9 to the negative first is the same as saying 1/8 plus 1/9. And we're going to make common denominators by multiplying by 9 over 9 and 8 over 8. This is 9 plus 8 over 72 is 17 over 72. I think we had those same numbers here somewhere. Now we're going to factor out the GCF of the polynomial for number 9 and number 10. So we start off with 24x to the 8th, y to the 9th, plus 24x to the 5th, y to the 7th, minus 30, x to the 2nd, y to the 4th. So I'm looking for the first, the biggest factor that's in common between 24, 24, and 30. So 30 is, well, let me show you how I would do this with the factor tree. We've got 24 twice and we've got 30. 24 is going to be 2 times 12, which is 2 times 6, which is 2 times 3. 30 is 2 times 15, which is 3 times 5. So I've got 1, 2 in common, and I've got 1, 3 in common. So the numerical part of the GCF is going to be 6. 1 second. All right. So now I need to look for the lowest exponent on x. So we're going to take the 6 out. We're going to take an x to the 2nd out because 2 is the smallest out of 8, 5, and 2. And on y, the smallest exponent is going to be 4. So those come out, and I'm going to divide each of these terms in my head by that GCF. 24 divided by 6 is 4. When I take 2 x's out of 8 x's, I'm left with 6 x's. When I take 4 y's out of the 9 y's that I see there, I have 5 y's left. Now I'm going to divide 24 by 6, and I get 4 again. Take 2 of the x's out of the 5 x's that are there, and I'm left with 3 of them. Take 4 of the y's out of the 7 y's that are there, and I'm left with 3 of them. Negative 30 divided by 6 is going to give me a negative 5. And we aren't going to have any x's or y's left because we pulled all of them out. This is my final factored form. And do that again here, but we're going to have a binomial as our GCF because we have the same factor appearing twice. It's a common factor that we can pull up front, and we can be left with the remaining part here as another factor. And there's my factored form. All right. We're going to look at some additional factoring techniques here. X cubed minus 6x squared minus 10x plus 60. We're going to When we see 4 more terms, we're going to try and factor out the greatest common factor from the first 2, the greatest common factor from the second 2, and see if the remaining piece is also common. That can be pulled out as a greatest common factor. And I'm going to factor this down to linear factors, even though it didn't tell me to. So that's something that you're going to want to practice for calculus, is when you see something that looks like a difference of squares like this, even if you don't recognize 10 as a perfect square, you know that it's the square root of 10 times the square root of 10. We're going to need all of the factors, even for things that are like x squared minus 10. If we can break it down into x plus something, x minus something in calculus, we want to do that. Number 12. So it's written kind of backwards. First thing that I want to do is factor out a -1. So I can write this the other way. Now that I have it written that way, I know that there's going to be 2 factors, and x times x is going to be in the beginning to give me x squared. I want factors that have the same sign that are both negative. I want factors of 28 that add to give me 11. Those are going to be 4 and 7. It's fully factored. Don't forget that that negative sign out there is part of your factored form. 15x to the third minus 65x squared minus 50x. We always start off by asking ourselves if there's a GCF. So we're going to factor out 5x to start off with, and that makes this 3x squared minus 13x minus 10. What do we do when the leading coefficient is 1? Well, we have some guess and check techniques. I also have other techniques. Let me show you how I would do this to be sure. I want 3 times -10 is -30. I want to list all the factors of -30 that have different signs. I want the bigger one to be a negative sign. So 2, -15. Oh, I can stop because there's a pair that adds to give me -13. So I'm going to have 3x squared plus 2x plus a -15x minus 10. So I've split the -13 up into a +2 and a -15, and we're going to do this factor by grouping thing that we have done. Let me erase this. Okay, so 5x on the outside, and then we've got x times 3x plus 2 minus 5 times 3x plus 2. So 5x times greatest common factor here, 3x plus 2 times remaining piece, x minus 5. Now, if you like the guess and check method, you could have from this point come down here and said 5x times, and then there's 2 sets of parentheses, and you could have said the only way I get 3x squared is with 3x and x. I have different signs because I have a -10 on the inside, and because I have a negative middle number, I'm going to guess that the 3 is going to go with the negative number because it's probably going to make the bigger product. That's just a guess. We'll fix it if we're wrong. Then I need factors of 10. Well, it's either 1 and 10 or 2 and 5. So we just think about it for a second, and we say 15 and 2 have a difference of 13, and I need a negative 13, so the 15 needs to be negative and the 2 needs to be positive. And I got my signs right. See, I got the same answer both ways, but this had a lot more guesswork. The method that I used first, there was no guesswork. I knew that I had the right answer. Anything that is like this with a leading coefficient that's not 1 that can be factored should be able to be factored by this factor by grouping method. So, all right, 9x to the 4th plus 18x squared plus 8. This one's different because the middle term is an x squared term. So that means that that's going to be the power on my factors here. The x squared times x squared is going to give me x to the 4th. But now I have a 9x squared. Did I get that 9x squared from a 3 and a 3 or from a 1 and a 9? We're going to do the same thing that we did just a second ago, where I'm going to say 9 times 8 is 72. I'm going to split that up into a way where the factors of 72 are 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12. There we go. That adds to give me 18. So 9x to the 4th plus 6x squared plus 12x squared plus 8. We'll factor by grouping here. Greatest common factor here is going to be 3x squared, and that leaves me with 3x squared plus 2 plus 4 times 3x squared plus 2. This is 3x squared plus 2 times 3x squared plus 4. We cannot factor these anymore because they are sum of squares, not difference of squares. So we have our fully factored form. Moving along to number 15. We have 10 p to the 1st q to the 4th minus 10 p to the 1st r to the 4th. So we're going to be able to pull out 10p as a common factor. And we get q to the 4th minus r to the 4th. Well, that's a difference of squares because q squared squared is q to the 4th and r squared squared is r to the 4th. This is going to be 10p times q squared plus r squared times q squared minus r squared. And give me 10p times q squared plus r squared is a sum of squares. It doesn't break down anymore. But q squared minus r squared is another difference of squares that breaks down into q plus r, q minus r. Okay. Now we have 1/25 minus p squared is 1/5 to the 2nd power minus p to the 2nd power. It's a difference of squares. So this is going to be 1/5 plus p times 1/5 minus p. 1000 p to the 3rd minus 1 is 10p, the quantity 10p raised to the 3rd minus 1 raised to the 3rd. This is a difference of cubes. The difference of cubes formula that says a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Similarly, there's a sum of cubes formula that says a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. We're going to be using the difference of cubes formula here, where our a is 10p and our b is 1. So 10p minus 1, 10p squared is going to be 100p. 10p times 1 is going to be 10p. 1 squared is going to give me 1. This is squared. check all your exponents, make sure that that's right. First set of parentheses is 10p minus 1. Second set of parentheses is 100p squared plus 10p plus 1. And that second set of parentheses should not factor anymore. We're going to do a sum of cubes down here in number 18 now. T cubed plus 64 is t to the third plus 4 to the third. So this is going to be t plus 4 times t squared minus 4t plus 16. Now we get something that just says factor completely, n to the fourth minus n to the third minus n plus 1. See how this is 4 or more terms? So we're going to factor by grouping. N to the third comes out at first. Then we're going to take a -1 out next. And we're going to factor that n minus 1 out. That leaves us with an n cubed minus 1, but n cubed minus 1 is going to break down some more into n minus 1 times n squared plus n plus 1. So I'm going to take these two n minus 1s and I'm going to write an exponent of 2 for them, since it was a repeated factor. And this n squared plus n plus 1 I'm going to write by itself. And I've factored completely. Now we've got just solving for one variable in terms of another. They've got a funky symbol here on purpose, just so you get the idea that it's the symbol for a circle. It's a circle with a dot in the middle of it. So solve for circle, we're going to multiply by q, and we're going to divide by b. Some good old Algebra 2 skills there. We're on number 21 now. 21 asks us to solve the equation 3/5 times the quantity y minus 2 is equal to 1 minus 3y. So 3/5 y minus 6/5 equal to 1 minus 3y. And then we're going to get our y's on one side by themselves. So I'm going to bring them to the left, 3/5 y, and I'm going to add 3y to both sides. It's going to be equal to, I'm going to add 6/5 to both sides to get my constants on the other side. And we're going to make common denominators. Make a common denominator here by multiplying by 5/5. Make a common denominator here by multiplying by 5/5. So we have 3y plus 15y over 5 is equal to 5 plus 6 over 5. Well, everything's going to be over 5, so I'm going to be able to multiply both sides by 5 in just a second. This is going to be 18y is going to be equal to 11, and y is going to be equal to 11 over 18, and that doesn't simplify anymore. If we wanted to, we could have gotten rid of the 5 way earlier up here by multiplying both sides by 5, then distributing the 3. We wouldn't have had any fractions to deal with. So let's just take a look at that, because I know that you probably don't love fractions, because I don't like fractions a whole lot either. Let's multiply both sides by 5 and see that we get the same answer. Now let's bring our y's over to the left. Let's bring our constants over to the right, and we still get the same answer. All right, now we're going to solve this absolute value equation. 9x plus 18 in the numerator over 2 is equal to 9. So first things first, I'm going to simplify things a little bit for myself. I'm going to write this as the absolute value of 9x plus 18 over the absolute value of 2 is 2 is equal to 9, which is the absolute value of 9x plus 18. It's going to be equal to 18. I'm going to factor a 9 out of this. The absolute value of 9 times the absolute value of x plus 2 is equal to 18. I know the absolute value of 9 is 9. So the absolute value of x plus 2 is equal to 2. So that tells me that x plus 2 is equal to negative 2, or x plus 2 is equal to 2. I'm going to subtract 2 from both sides, both of these equations. X is equal to negative 4, or x is equal to 0. Check your work if you would want to. 9 times negative 4 is negative 36. Negative 36 plus 18 is negative 18. Negative 18 divided by 2 is negative 9. The absolute value of negative 9 is 9. Stick 0 in. 9 times 0 is 0. 0 plus 18 is 18. 18 divided by 2 is 9. The absolute value of 9 is 9. These are both good answers. Now we're going to solve the absolute value of 7x plus 4 plus 10 is equal to 3. We got a problem here because when I subtract the 10 from both sides to isolate the absolute value function, the absolute value equals a negative 7. There's no solution to that because absolute values are distances that have to be positive or 0. They can't be negative. So can't have a negative distance. There's no solution to that. Moving on to number 24, which is the beginning of the second page, about halfway done. Solve the equation, the absolute value of 9x plus 9 is equal to the absolute value of x plus 4. So we're going to have let's see here. One of the things that I can do here is to say 9x plus 9 is equal to exactly this, or 9x plus 9 is equal to exactly the opposite of that. And that'll work. That should give me my two answers. So subtract x from both sides, add x to both sides. Subtract 9, subtract 9. The left one divide by 8. The right one divide by 10. Let's graph this though, and let's prove that those are the only two answers, because you may not necessarily see the algebra that I just did there. So this is going to be y equals, and I'm going to have math, number, ABS, 9x plus 9. It's my first equation. And I'm going to have, if we just subtract the 2, let's go ahead and subtract the 2, because then we're going to get minus math, number, ABS, x plus 4, zoom 6, and I'm going to see where the zeros are here. So second calc 0, the points of where it crosses the x-axis here are going to be negative 1.3, which is negative 13/10, and second calc 0 negative 0.625 is negative 5/8. Show you that that's negative 5/8. Come out here and get that x value that it just gave me and say math, answer to fraction. There it is as a fractional form. So those are our two correct answers. Let's clear this. X squared plus 6x minus 16 equals 0. X plus 8, x minus 2 is equal to 0. X plus 8 equals 0, or x minus 2 equals 0, x equals negative 8, or x equals 2. X times 5x plus 8 is equal to 4. 5x squared plus 8x is equal to 4. 5x squared plus 8x minus 4 is equal to 0. Take your pick if you want to factor, if you want to use the quadratic formula, if you want to complete the square, how you want to do this. I'm just going to jump into the quadratic formula to practice that. So it's going to be negative b plus or minus the square root of b squared minus 4ac. So that's going to be plus 80 over 2a is 10, negative 8 plus or minus square root of 144 is going to be 12 over 10. So this is going to be equal to negative 8 plus 12 is going to be 4 over 10, or negative 8 minus 12, that's going to be negative 20 over 10. X is equal to 2/5, or negative 2. We could have solved that by factoring. We could have completed the square to solve it. Lots of things, but I just wanted to, because the leading coefficient wasn't 1, I wanted to practice using the quadratic formula on it. X squared over 90 plus 1 over 10 is equal to x over 9. There's no reason to not just multiply by the LCD here to get this to be x squared plus 9 is equal to 10x. X squared minus 10x plus 9 is equal to 0. We'll factor and say x minus 1 and 9. 1 and 9 add together to be 10. X minus 1 equals 0, or x minus 9 equals 0. X equals 1, or x equals 9. Use the square root property to solve the equation. So we've got x minus 6 quantity squared is equal to 36. So that's going to make x minus 6 is equal to plus or minus 6. If x minus 6 is equal to negative 6, or x minus 6 is equal to positive 6, then we'll add 6 to both sides on both of these equations, and we'll get that x is equal to 0, or x is equal to 12. We only use the square root property with the plus or minus part when we start off with a squared. If we start off with a square root in the problem, you don't have to add plus or minus to your answer. Quantity 2x plus 5 quantity squared is equal to 6. We're going to take the square root of both sides, plus or minus root 6. 2x is equal to negative 5 plus or minus root 6. X is equal to negative 5 plus or minus root 6, all divided by 2. Those look like answers from the quadratic formula. They would have been if we would have had it all expanded and had our A, B, and C. Let's solve the equation. X to the third plus 9x squared plus 18x is equal to 0. We're going to factor out the GCF of x first. 18. Factors of 18 that add up to be 9 are 3 and 6. X equals 0, or x plus 3 equals 0, or x plus 6 equals 0, x equals 0, or x equals -3, or x equals -6. Five x to the third plus 3x squared is equal to 20x plus 12. We'll get that all on the left-hand side here. It's 4 more terms, so I'm going to try to factor by grouping if I can. Minus 4 times 5x plus 3. This is 5x plus 3 times x squared minus 4 is equal to 0. 5x plus 3 times x plus 2 times x minus 2 is equal to 0. 5x plus 3 equals 0, or x plus 2 equals 0, or x minus 2 equals 0. 5x equals -3, or x equals -2, or x equals 2. X is equal to -3/5, or x equals -2, or x equals 2. Moving on to number 32. X to the third is equal to 121x. X cubed minus 121x is equal to 0. X is a common factor. X plus 11 times x minus 11. X equals 0, or x plus 11 equals 0, or x minus 11 equals 0. X equals 0, or x equals -11, or x equals 11. Number 33. X times 6x plus 7 times x minus 1 is equal to 0. It's already factored for, so x equals 0, or 6x plus 7 equals 0, or x minus 1 equals 0. 6x equals -7, x equals -7/6, x equals 1. X to the fourth minus 7x squared plus 12 equals 0. Factors of 12 that add to be -7 are -3 and -4. These are both difference of squares still. X plus √3, x minus √3, x plus 2, x minus 2. Set each of these equal to 0, or x minus √3 equals 0, or x plus 2 equals 0, or x minus 2 equals 0. Go. So x equals -√3, or x equals √3, or x equals -2 or x equals 2. Fourth degree polynomial could have up to 4 answers to it. All right, solving some systems of equations here. Have number 35 has the system of equations 1/3 x plus 1/3 y is equal to 2. X minus y is equal to -2. Just going to rewrite that by multiplying the top one by 3 as x plus y equals 6. The bottom is x minus y equals -2. I'm going to use the addition or elimination method because y and -y will add to give me 0. So that's 2x is equal to 4. X is equal to 2. I'm going to come back to the equation x minus y equals -2 and say 2 minus y equals -2. Negative y is going to be equal to -4. So y equals 4. And my solution is going to be the 0.24. Stick it in if you want to. 2/3 plus 4/3 is 6/3. 6/3 is the same as 2. 2 minus 4 is -2. This is the solution to the system of equations. Now we have 1/5 x plus 1/5 y is equal to -1, and 1/5 x minus 1/5 y is equal to -3. Again, I'm going to get rid of the fifths. X plus y equals -5. X minus y is equal to -15. So we're going to use addition elimination again to say 2x is equal to -20. X is equal to -10. I don't care which one I use. Let's use the first one, that when I stick -10 in, I get -2 plus 1/5 y is equal to -1. So 1/5 y is equal to 1, y is equal to 5. This is -10, 5, 2, -2 plus 1 is -1. -2 minus 1 is -3. That's right. Moving right along to number 37. Find the slope of the line, given the 2 points on the line, 0, 0, and 2, -5. My slope is going to be y2 minus y1 over x2 minus x1, being -5 over 2. Again, 2 points determine the line, but they also determine the slope of the line. We have 0, 4, and 3, 3. y2 minus y1 over x2 minus x1 is going to be -1 over 3. Now we have a vertical line here where the x coordinates are the same. The slope of that vertical line is going to be undefined because vertical lines have undefined slope. Now we have a horizontal line for number 40. Horizontal lines have a slope of 0 because there's 0 change in y for our change in x. And we are going to find the equation of this line, I believe. No, we're going to find the slope. So the slope for the line connecting the points 0, 0 to 4, -5. Again, it's y2 minus y1 over x2 minus x1 is going to be -5 over 4. And then interpret the slope. That means that for every 4 units that I go to the right, I'm going to go 5 units down. This is a rate of change here for whatever this unit is this way. Like, let's say that this is gallons of gasoline, for instance, and this is miles here. You're going to get a rate of change of miles per gallon, something like that. Or you could have time here and distance here, and you could get feet per second. It's negative, which means that it's decreasing. So that's important to know, that a negative slope is a decreasing function. Number 42, the price of a certain commodity is a function of supply and demand. The table below shows the price of the commodity per barrel between 1995 and 2000. Find the average annual rate of change between 1998 and 2000. So to find average rate of change, it's f of b minus f of a over b minus a when I'm evaluating f of x over the closed interval a, b. So I'm going to take my left endpoint here, 35, minus my right endpoint. Now it says 1998, so I'm sorry, right endpoint and left endpoint. So it's $12 here. Don't go all the way back to 1995 because it says 1998 to 2000. So then we need 2000 minus 1998. So in the numerator, we're going to get 23, and in the denominator, we're going to get 2. So this is going to be on average $11.50 per year is the average rate of change. Now we're on to number 43. Find the equation of a line with a given slope and containing the given point. So we're going to use the point slope form here. Y minus y1 equals m times x minus x1. So y minus, well, they give us the y-intercept there. So we're just going to use y equals mx plus b because they gave us enough information to do that. So y equals mx plus b. These other ones, they don't give us the x coordinate of 0, so we can't do that so easily. The others, 44, they tell us that it's a horizontal line by saying the slope is 0. So that's y equals a constant. So that's going to be y equals the y value of 1. 45, they tell us has undefined slope. So that's x equals a constant. And our x is -2. Only in the last problem here do we need to use this point slope form. So we're going to do that. M equals -7.6. And we have the 0.45 on the line. So this is y minus 5 equals -7.6 times x minus 4. Y minus 5 equals -7.6x plus 24/7. I'm going to add 5, but I'm going to add 5 in the form of 35/7. 35/7. That's 5 that I'm adding to both sides, -6/7 x. And this is going to be plus 59/7. (5x minus 7y is equal to 8). Now we want to find the x-intercept and the y-intercept. So make a table here, x, y. First, I'm going to let x be 0. And when x is 0, that means -7y is equal to 8. So y is equal to -8/7. Now I'm going to let y be 0. And that means that 5x is equal to 8. And x is equal to 8/5. Okay. Going to use the given conditions to write an equation of a line in slope-intercept form. So it's going to go through the point 3, 6. It's going to be parallel to 5x plus 4y equals 47. So I need to find the slope of this line that it's parallel to by solving for y. 4y equals negative 5x plus 47. Y is equal to negative 5 fourths x plus 47 over 4. The y-intercept is not important to me there. I need the slope. So my slope of this given line, since they're parallel, they have the same slope. My slope of this line is going to have to be negative 5 fourths as well. I've got a point, I've got the slope. I'm going to use point slope form. And I'm going to solve this to slope-intercept form because that's what the instructions told me to do. This is over 1. I'm going to change it to 4 over 4. So I'm going to add 24 over 4 and a 24 over 4. This makes this y equals negative 5 fourths x plus 39 over 4. Now we've got negative 4, 1, and perpendicular to, that's the symbol for perpendicular to, 3x plus 2y equals negative 16. 2y equals negative 3x minus 16. Y equals negative 3 halves x minus 8. My perpendicular slope here is negative 3 halves, so my slope over here needs to be the reciprocal and change the sign. So it's going to be 2/3. So now I have y minus y1 equals m times x minus x1. And add 1. And add 1. And there we go. Now we're going to solve a couple word problems, and we will be done with this video. When 4 times a number is added to 7 times I assume that's the number. So 7 times the number. The result is 55. Sorry that it got cut off there. What is the number? So 4 times the number added to 7 times the number makes 11 times the number, and the number is going to be 5. Gary can hike on level ground. At 3 miles an hour. Faster than he can on uphill terrain. Okay, 3 miles an hour faster. Yesterday he hiked. There's my formula I'm going to be using. Yesterday he hiked 33 miles, spending 2 hours on level ground and 5 hours on uphill terrain. So 2 hours on level ground, 5 hours on uphill terrain. So my distance that was level ground is going to be 2 times x plus 3 is 2x plus 6. I'm going to add that to 5x, and my total distance is 33 miles. 5 plus 2 is 7. 7x is equal to 27. and 5 by 7. X is equal to 27 over 7. We don't talk that way though in the real world most of the time. So if we're talking miles per hour that he can hike, we're going to say X is about something like this. We'll round to a decimal point. It's appropriate that the teacher gives us. This is the exact answer. That's why I have an exactly equal to sign. This is an approximation. That's why I have an approximately equal to sign with those squiggly lines. It's important to show the approximation when you do approximate, but we show approximations because we're not going to be talking to people using fractions and square roots and things like that lots of times, unless we're talking to engineers who need exact answers. If we're talking to people in the real world, we want to talk about a speed or a velocity. We're going to talk about it in miles per hour with a decimal point, so they can say, yeah, I can get a grasp on what that is. 3 and 8600ths is a lot easier for people to comprehend than 27/7 miles per hour. All right. That's it for this video. See you again next time.